All right, so I think this is recording. We've been taking a look at skill packet 3, which is relations and functions, and specifically a subskill that allows us to look at operations on functions. And we found out that it was like we would expect, that you can add two functions together and get a new function, subtract, multiply, divide, and all get a new function. There is a new operation called function composition that we can treat kind of like an assembly line, like I've pictured here, where you input a number into the first function, and the output of that function becomes the input of the next function. And whenever we have functions, we often, almost always, are interested in the domain of the function. So here I'm going to go through and find the domain of this function composition f composed with g. So two things have to be true to be in the domain of this fog of f composed with g. First, the number that we're inputting out here, this x, has to be in the domain of g. Otherwise, it wouldn't make it through the first function. Whatever number we plug in, we have to get a number as an output, not something that's undefined. Next, the second thing that has to be true is what comes out of g, the output of g, which we write in function notation as g of x, that has to be able to pass through, that number has to be able to pass through the function f. It has to be in the domain of f. So both of these things have to be true for a number to be in the domain of this function composition. So let's find the domain of g. Well, it's pretty easy because we don't have any square roots and we don't have any variables in the denominator. So the domain of g is all real numbers. That's kind of nice. There's no restriction. Any number that we give to g, g is just going to multiply it by 3 and then hand that off to f. Well, let's look at the domain of f. And again, it's going to be pretty easy because we don't have a variable in the denominator and we don't have any square roots. So the domain of f is all real numbers. So f loves all of the output that g produces. Anything that g gives it, f is fine with it. So any number that we plug in the beginning of this, as an input to g, guaranteed we'll have an output all the way through after it's passed through both functions. So the domain of this fog for this problem is all real numbers, because this and this had to be true at the same time. So when you intersect the two sets here, we have all real numbers. All right, so let's go on to the second one. Two things always have to be true to be in the domain of this fog. One is that the input to g has to be in the domain of g, and two, the output of g has to be in the domain of f. So it's normally pretty easy to see what the domain of g is. Here, we don't have any square roots, but we do have a variable in the denominator. We need to avoid division by 0, so we do not want to put in a 0 into this function because 2 divided by 0 is undefined, and we would have no value to input into f. So there's not going to be a final answer out here if we try to input 0 into this function. 0 is not in the domain. All right, so what about, will all numbers make it through f? Well, I don't think so, because f doesn't have any square roots, but f does have a variable in the denominator. The output of g, if we tried to input a 1 into f, we're going to have 3 divided by 0, and that's undefined. So we do not want the output of g to equal 1. Well, we need to figure out what input into g causes an output of 1, and then avoid that, prevent that from happening. So we temporarily, hey, let me pause this real quick. All right, so hey, I'm back. All right, now, we do not want the output of this function to equal 1, So we need to temporarily set this equal to 1 so we can figure out for what value of x would cause an output of 1. So if g of x is 2 divided by x, and we set that equal to 1, we can just solve this proportion by cross multiplying, and we can see that x is equal to 2, or by inspection you can see that 2 divided by 2 is 1. So what this is telling us is that if you input a 2 into g, you'll get an output of 1. If we put a 2 in here, then g will, it always takes 2 divided by the input, 2 divided by 2 is 1, and then f freaks out. F goes, no way, I refuse to work with the number 1 because it gives me a 0 in the denominator, and it yells at g, hey, I don't know what number you just plugged in, but don't do that. So we're going to throw 2 out of the domain. So g refused to work with 0 because of the same idea. It caused division by 0. And now we have to throw out the number 2 because the output of g is 1 and f refuses to work with 1. So we've got the domain as a set of all real numbers, excluding these two values, 0 and 2. So the domain of fog is from negative infinity to 0, from 0 to 2, and from 2 to infinity. All right, so I'm going to do these 2 per video. So hey, I hope that helps, and I'll talk to you later.